Okay, sorry for being late. So in our last class, we started implementing some of the object-oriented features in using C++. So what we did is to declare a C++ structure, and what we found, the key difference between a C++ and C structure. C++ structure versus class. So there were a lot of similarities, but there are few differences also. So both of them allows wrapping up member data as well as methods. So this is the first thing, and it says that so earlier if we because C++ was C compatible, in C there is no possible way you can wrap data with methods, but in C++ structure, when both the structure and class, both of them, so they can wrap up both member data and member methods. So this is one enhancement of C++. And here in a C++ structure or class, data, members need to be tagged as public or private. Okay. So these are called the using tagged using access specifiers. This may be public or private. We are leaving the protected right now. So any data members, that means member data as well as methods. Okay. So this is another additional feature, because in object-oriented programming we want more control over data also, in addition to procedures or methods. Now the basic difference, so these are the similar things. The basic difference is between structure and class is that the default specifier, access specifier in a structure is public, but the default access specifier in a class is private. Okay, so this is a basic difference. And why this is given? Because if you just copy your C structure code, the code having a C-like structure definition, so if you just copy it in a C++ compiler, it would have worked nicely without any further changes. So that means, because there is always a tagging of access specifiers in C++, so in case of structures, until and unless the default is public, this will not work, right? Because you have not tagged anything, and you should be able to access, because in C, if we define members, now using a instance of that particular structure or structure variable, using the dot operator, we can access those data members. So the nature is, if you think of the nature, it is by default public. So that's why there is a change in the default. So it was just to make it compatible in terms of the C structure, the prior codes that we have written. But if it is a C++ object-oriented programming, we probably will not have the case where related methods which are related to certain type of data should be left in isolation. So we would like to have wrapping of members as and when required. But there are there may be some exceptional cases where structure or class, they may have only data members and no methods. So we may have some kind of extreme definitions where we have only data members but no methods. Or we can have the other option also. We may have only we may have no data members and we can have only methods. Okay, although the first one seems to be acceptable, because in earlier structures also, C structures also, we just had data members but no methods included. But the second one, declaring a structure or a class, just packing few methods without any data members, seems to be a bit strange, I mean surprising. But this also is allowed, and whether and when it is allowed, when you require to have a design something like this, you are defining a class without any features, just having some actions defined on it. So that we can see later on in some cases, I mean if your design is like that, you can do that. So it is just for completeness it has been provided, but in some cases we may need that. And specifically in this particular case, or okay, I mean let us put it in a different way. The size of an object or an instance, which is basically an instance of a structure or a class, is equal to the combined size of its data members. Okay, so the size of object, size of object is equal to the combined size of its data members. So in this particular case where you have only methods to take care of that, so in that case, once we initialize, or I mean once we declare object or instance, so object which is declared, even though there are no members, we need to have some dummy space allocation for that through which it manifests. So in this particular case, the object size will be is equal to just 1 byte, which represents a dummy allocation. So this is to be remembered. So that what we discussed in our last class. Is that fine?
Yes, sir.
So I don't think there are, because right now we don't believe on these points, rather we have experimented and found that these are true. So the point is, from now onwards we will not use the keyword struct, because we saw that they are actually similar apart from the default one and all this. So we are not going to use anymore the keyword structure. Okay, from now onwards, when we write codes where we require wrapping and all this, because we should stick to the C++ terminology or object-oriented terminology. So before I get into the actual code of writing the stack class, so in this particular lecture, I will talk about writing the stack data structure, implementing the stack data structure by defining its class. So this is trivial, but I'll mainly focus on the syntactic part and how to write the class, what we should do and what we should not do, and gradually see that how it works. Okay, so the scope resolution in C++. So this is the operator. So this looks something like this. This. So this is the operator that we are talking about. Okay. So let us assume that we have got integer variable int a equals to 10, and now within the main you have got another variable declared in the same name as 20. Okay, so this is the global and this is the local copy of a. So if we give here cout a, what do you expect? What will be displayed?
20.
So if I just write a, so definitely because you have got a local copy, it will be displaying 20, right? So this will be 20. I think all of you will agree. So we know that in C++ we can declare a variable at any point that we wish, right? So if I write, here cout a here at this point, will it work?
Yes, sir.
What will be the answer then?
10.
Yes, sir.
No, sir. Work.
Yes.
10.
Will it not work? I mean, somebody says no. So what do you think? Why it will not work?
Sir, before declaring the A will be required, sir.
So I say that you are declaring the local copy of a here, but if you call out, or if you write out a here, so you may not have a local copy. So ignore this one. If you don't have any local copy, but if you write out a, what do you expect then? If you don't have a local copy declared, if you just write cout a having a global copy, what do you expect then?
Sir, it will print 10, sir.
So he who was asking the question, or what? So are you getting the point? So if I don't have a local copy, then what will happen? It will just say that, okay, I don't have a local copy. So do you have a global copy? The answer is yes. So there's a global copy. So if there's a global copy, so the point is at this point, when the compiler starts compiling, it comes and parses it here. It will say that cout a. Okay, there is no local a that has been defined yet, but there is a global copy. So what it will go on displaying is here 10. That means a global copy will be displayed. Is that fine?
Yes, sir.
Now the point is, now at this point you have declared the local copy. So once you have declared the local copy, then definitely, so obviously within your scope, if you have defined this with the same name, and if you don't specify anything, if you just write a, it will give the local copy and it will ignore the global copy, right? Now the point is, so this is fine, up to this is fine. So at this point, if I want to display the global copy also, is there any way out?
Sir, the scope resolution operator, sir, if we put that before A.
Which one? Scope resolution. So thing is, if I write here, so what do we expect? I mean, what will happen here? So those who are first time C++ coders, so just know that if I write this, it will display 10. So got the point? So if you have a global copy and if you have got a local copy also with the same name, then if you just write after declaring the local copy, if you display just the name of the variable, it will definitely without any ambiguity, it will just display the local copy value. But in presence of the local copy with the same name, if I would like to access the global copy of it, because this A and this A are not the same, so then I can do it using this particular operator that I just now mentioned. This is the scope resolution operator, right? It looks like that. There are two characters involved, so it will give it. So we can have access to both. Now where the global is stored, the global copy, where it is stored, which segment? Quickly, which segment this global copy is stored?
Data. Data
Data
set.
segment.
Data segment. And which copy this local copy, which segment local copy is stored?
Stack.
Stack segment. Okay, so this is also A and this is also A, but they two are different A's because they have got a different scope and the purpose is different. They are, so the thing is, in no way you can have the same name. You cannot have variable, two variables with the same name in the same segment. That is not possible. So you cannot have another A here, but you can have one A here, another A here. This is possible. That's why local and global can coexist at a particular scope. Means global has the scope, it's a global scope throughout you can access it. But if you create a local scope with the same copy, it does not clash with the global one because they are not residing in the same. Like you can have uh, some name, say some name in the CS department and some the same name maybe some other student in the EC department. That is possible. But in the same class, in the same batch, if you have got uh, two students having the same name, there is a clash and it is not allowed probably. So in that case, somehow you people also resolve it in some way. You add the surname or you add some other names and all this. So this is how it is done. So this is one use of the scope resolution. So why it is called scope resolution? Because it basically resolves the ambiguity. That's why it is called resolution operator. So it resolves ambiguity. What ambiguity resolves? It resolves ambiguity that whom to call, because these both are A's, global and local. So it resolves the ambiguity which is created and due to the different scope. Okay, that's why it is called scope resolution. Okay. So now if I, so can you just quickly tell me the outputs of this code? So right from this first one here. So it's a global copy, it's a local copy. So what will be displayed here?
10.
10. What will be displayed here?
20.
20.
20.
Then 10.
Here 20. What about here?
10.
What about here?
30. 30.
See, the point is, if I here, if I sorry, if I write like this, those who are C coders, pure C coders, so will this be allowed? I just write these two and write something here, C out A. Will this be allowed?
No, sir.
If I just write these two, will it be allowed? In a C,
No, sir.
in the C notion, it will not be allowed because it does not make sense. C says that if you write a for loop, there you can write this and write something here. If you have a while loop, you can write this, or within the main or some other function you could write and you can write this like this. These are possible. But the thing is, in C, you see, or maybe I write something like this. So there is a function, and within which you are at a for loop or a while loop and all this. So the thing is, so in C the scopes are created in terms of the function, right? So within this function you have created a scope, local scope. Within the main you have created local scope like this. Okay, but within the, having this entire scope, you cannot create another nested scope here. In C you cannot create nested scopes within the function scope like this, right? So this is not possible. You will immediately give an error message. Is that fine? So such scopes within the function scope cannot be created anymore. Is that fine? But in C++, this is perfectly allowed. So this one is perfectly allowed. So we can say that, say, just a minute. Say we can say this is the blue scope which is created within the original green scope. So green scope is always there because this has created a scope within which if you declare something local, that will be only valid within that scope, the whole green scope. But now you say that within the green scope I have created a blue scope also, which is nested. Okay, so this is another scope that is created. So in C++, this is perfectly okay, this is allowed. Such nested scopes can be created within a function scope. Is that be strange that why we do this? What's the point of just creating out of nothing a scope within a function scope? That might be looking strange, but I'll come to that why this makes sense. We'll come to it, but let us first accept that this is possible. Okay, so if this is possible, then if I just write, I may just leave it as blank, no statements, but I create a scope. But if I give this cout a, what do you think? What will be the display here? What value it will be displayed here?
20, sir.
Will it be 20 or will it be 10? Because
10.
now you say that within this local scope, do you have any explicit declaration of a within this scope? Now I say this is a blue is a scope. So within this scope, have you declared anywhere a?
No, sir.
So if you have not declared anything a, so it might go and display the global a, because if you have not a local scope, it will display the global. So will it, so is that valid? Is that logic valid? Are you getting my question? Are you getting me?
No, sir.
Yes.
So here the thing is, let us accept the fact first. So here the output will be also, what will be the output? 20.
10.
The output will be 20, not 10. So now what will be the refined logic? So if you have created a local scope within another function scope, we can create any number of nested scopes. So within that scope, if we don't have a local copy declared explicitly, that what we have not done here, it will go to the outer shell. Instead of going back to the global, it will look one step back. So it will move up and it will find out if you have declared something here corresponding to a. There is indeed a copy of a that we have declared. I mean, within its immediate outer global scope above it. Okay, if you have done that, it will display that value here, or whatever has been modification has been done. Is that okay?
Yes, sir.
So it will not jump immediately to the global looking for global, but rather it will because it's a nested one, so the outer scope that it is immediately encapsulated within, it will look into that scope whether you have got a local copy. If you have not that, it will go on like that. And if you have not found anything of that, so it will go and access the global copy. That is how it works. Okay. So here if you have done this, so it will be a equals to 20. Now here if I declare the int here, int a equals to 30, what do you think? What will be the output of a?
Sir, will you declare it before cout or after?
Now after cout, I have just mentioned it here after the cout.
Then
20.
20 only. Sir.
It will remain 20 because you see when the compiler came at this point, it never found a declaration within your local scope. So it will definitely move up the outer one and will find out 20. Now you have made the declaration at this point, will not have any impact in the previous statement because it says that. So the thing is in C++ you are free to declare anywhere you want a variable for the first time if you like to use it, so you have to declare it. So if you have not declared it but still you are calling the name, it will look to the outer scope and try to find out if there is a name that has been valid in the outer scope already alive and whatever. If it is there, it will work. If it is not there, it will go on seeking the global scope. If it is there, it's fine. Otherwise, it's not declared, right? Now, if you have declared it after that, I mean, something after the cout you have declared, so it will be valid after that only. So if you write a cout here, then this 30 will be displayed, otherwise not. Got this point? And at the same time, using this scope resolution operators, you cannot, it's not only just for say accessing the values, that's it is 10 or 20 or whatever, but you can update, decrement, increment, do whatever you want. You can reassign whatever you want. So the thing is, if I write here plus this, that means it will not only access, but it will basically ask you to increment it. So it will be 11 in that case. Got the point? So using the scope resolution operator, you cannot just only access the value, but you can also update the value. Just write plus whole of that scope resolution a. So scope resolution means it's a global copy of a. You can update, you can decrement, you can increment, you can do whatever you want. Okay. So now let us get back to it and try to find out the output of it. So I have declared here 30, so it will be 30, right? So this nested scope is perfectly fine. So we have created another scope within this main function scope, and because you have already declared, so within its local scope you have got a copy of x, the same name. Here is x, here is x, here is x. And if you look into the stack segment, you have got this x equals to 10. Corresponding to this x, you have got x equals to 30. Okay. And this x will be in some other, like in the heap segment, in the data segment, this is say x equals to 10. Sorry, this is x equals to 20 and 30. Okay. So here, what will be the value here?
10.
It is always 10, no matter wherever you call from. If it is a global, if there is a global variable, it will always display the global variable. But if you don't have a global variable, if you call this scope resolution x, what is going to happen? If you don't have a global copy declared, but you are still calling scope resolution x, then so it will not apply. Yes.
Invalid.
Yes, I mean the compiler will not put any intelligence in it. It says that this scope resolution x means it is only to resolve global ambiguity. So the global, it will try to refer to the global copy. But if you have not got a global copy and if you are trying to use it, it's meaningless. So it will give an error message. Okay. So what about here? What value will be displayed here?
20.
20.
It will be 20, right? Because when it comes here, you can assume that because this scope is over. So this scope is over means this x equals to 30 actually is popped out, or it is no longer valid. Okay, so you can simply ignore it. When it comes here, you can simply ignore this part. So that means what you have declared the value of local copy of x here, you have not modified it. So at this point, if you want to use, it will be basically 20. And again, if it is this, it is a global copy 10. Is that fine?
Yes, sir.
So now quickly tell me the output of this one. I think it's exactly the same. So can you tell me the output of this one? So this is 10. 20 is declared. So what will be the value here? 20 and 10. Then here you have within the scope you have declared it. So what happens in the local scope? There is no declaration of x. It will move up in the scope outer to it, and it will find what
20.
value it is listed.
20.
It will be 20, and then here again it is 10. No matter wherever you call from, and you have declared x. So here if you call, it will be the local copy that it has got its own copy now. It will not seek from others.
10.
This is 10. Again within this, so there is no
30
local
and
copy. It will start copying 30, then 10. Here
30.
there is no copy.
Same.
So the thing is, you see, there is no local copy here. In the outer scope, there is no local copy. It will go outer to outer, it will find 30. So that is how it keeps searching for moves up and basically searches through the outer scopes if somebody has got a local copy. Otherwise it will refer to the global copy. But the global copy, if it is not there, this will, anywhere you call it, it will give an error message. So from here, if it is here means, so there is no definition here. So what will be displayed?
30.
30, and this is 10.
30, 10.
And you have got a definition 40, but there is no use of it, because in any way when the the control comes out of the scope, this becomes invalid. Okay, so here again if I call, it will be
30.
so you can ignore the whole
30.
scope. So it is 30 is valid here, and this is 10.
Sir,
And
11.
hmm?
11 or
Oh yeah, this is 11. Yes, I've incremented it. So here I'm incrementing also, not just merely accessing it. So at this point it will be x will be, so out of this scope, so
20.
this scope is no longer valid, so x equals to 20. And then this is again the same global was
11.
earlier 11, now it becomes
12.
12, right?
12.
Okay, so if I write, say for example, if I declare here int x equals to 50 here, what is going to happen? Rest of the things kept intact. If I just write this,
Sir, 30 will change to 50 everywhere.
hmm?
Below it.
Listen carefully and
Between
answer.
50 to 40. Everywhere the 30 will
Hello.
be changed. Between int x equals to 50 and between int x equals to 40, everywhere the
There is, so within this scope, you see, within this particular scope, there is x equals to 50 and x equals to 40. So within a single scope, can you have two declarations, two local declarations of the same variable name?
No, sir.
Got the point? So it will give an error message, because now it's becoming too much, because uh, sorry. So here this is not allowed. I mean either so, hmm?
simply overwriting is possible, sir. Again, if we declare it is not, it's not possible.
That is what it is. But I am declaring it here. No? So I am declaring. So int means it's a fresh declaration. So two simultaneous or multiple declarations of the same name within the same scope, it is not possible. That's why. So definitely it would have pointed out here itself. So either you can retain this yellow one, or you can retain this one as you wish. But you cannot simply have two declarations, two local declarations with the same scope with the same name. Got the point?
Yes, sir.
Yes, sir.
So this is a summary. A pair of parentheses can be used to create nested scopes within a function body. Then this scope resolution operator is used to access the variable in the global scope, and mainly used to resolve the conflict where there exists a variable with same name in the local scope too. If there is no global scope declared, use of this displays an error message that we already mentioned. One can update the global copy too using this or this, whatever you want. Whenever we access the local copy of a variable that is without the scope resolution, the compiler moves up to find a local declaration of the variable within the current scope, or it scans upward to find a local declaration within its outer scope. It goes on like this till it reaches the global scope. It keeps on resolving like that till it reaches the global scope. But in between, if it gets a local copy declared in the nested outer scopes, it will use that. It will consider that. Okay, so this is a summary of this scope resolution operator. So now let us write the a C++ code for implementing the stack. Just a minute. You can answer that. Okay, sorry. So okay, let me just summarize this and then I'll get back to the code. So in a typical procedural approach, I'm using C++. I'm using C++ compiler, but I'm using procedural approach. So if I would like to implement a stack, what I should have done? So stack, what it composed of? There is a variable called top, which points to the top of the stack. There is a variable called say maybe size. So top points to the topmost elements index. S, the size points to the so it actually holds the maximum size of the stack. So if you have got a stack of say 5 elements at most, like this. Okay, so this is the closed end. So this, in this case, s equals to will be 5. If you have got 3 and 2 stored here, so top will be pointing to this. So top, so it's not pointing, top will be actually assigned to this 0, this is 1, this 2, then 3, then 4. So top will be storing the value 2, sorry, 1. Okay, so we can have this variable top, we can have a variable s, we can have another variable n which counts the number of elements. So in this case it is say 2. And in case of stack, so which one, what type of data structure you prefer to implement a stack? Linked list or an array? Can stack be implemented using both linked list and array?
Yes, sir.
Which one would you prefer if nothing is asked explicitly?
Array.
Because array, it is there any problem in using an array? It is pretty simple, because here the insertion and deletion is taking place in one end that is open, and so if it is 0 1 2, so the array, if you have declared an array, the elements will be pushed from this on the top of it like this, and it will be deleted also from this side. So the only point where we don't prefer to use an array is if the insertion deletion takes place in the middle of the list, right? But in stack there is no such possibility, because it is strictly the insertion deletion takes place in one end of the list, only in one end. So that's why the default and the preferred choice of implementing stack is array. until unless you are forced, and nobody asked, I think, will ask you to implement a stack using linked list. So you should not do that also. Okay, but this the allocation of this array where you should hold the elements should be dynamic. It should be a dynamic allocation. So the point is we can have another variable a, which is basically a pointer which will be pointing to this base address. I mean, so the base address, you can say it is pointing to the starting address. Okay, this points to this. So within the stack, if we would like to implement a stack, how many variables we should declare, how many data members or how many variables we should declare?
4.
Say as per the design says it is 4. I mean, that we have discussed till now. You can have less also. This n is of no use, but let us assume that we have got 4. Now, because they are all related, we are going for a procedure oriented design. So here all these 4 should be grouped together because they are cohesive enough. So we should write here struct stack, and we should have the declaration like this: int top s n and int asterisk a. Is that fine? So that's a end of the structure. So the stack structure is defined like this, and as we mentioned, there is no type def required, there is no variable declared, so it's like this. And what we have, so here generally we'll have a set of methods. What are the methods here? Pop, push, pop, display, and what else?
Is empty, is full.
Then yes, that is empty, is full, and what else? Create stack, or init stack. You can say it's init stack, initialize the stack, where it actually allocates the space of this 2D array, 1D array based on the size that you specify, and it will initialize the top, initialize n, s, and all this. So it's basically init stack. Again, it is as per my design, say for example, init stack. And as you have got init stack, you will have a clear stack also. Okay, it will be basically deallocating the space. So that's 1, 2, 3, 4, 5, 6, 7. So 7 methods are good enough. So if it's a procedure oriented approach, so probably you will not be able to, although you know that these are cohesive, they two are related, you cannot put them inside here. I mean, it's a pure C like. So you should be you should be forced to say write here the prototypes. Here this is push, pop, then display. Okay, so what will be the prototype in each of these case? What will be the prototype here? What they should accept? Push will accept what?
So one integer
What else?
and a
The
struct.
top point.
Not the top pointer. What else it will require? Because you see, what is a stack? So stack is so we have encapsulated, or I mean we have actually grouped them all together in this structure, right? So in the main, if I declare stack,
So your voice is cracking.
So what do I do? Stack S1. So if I would like, so what is the first thing that I do? I have to initialize, right? So if I have to initialize it, I have to call init stack, right? So init stack. So which stack to initialize? So I have, say for example, I have got 2 stacks defined. So right, but I have to initialize them. I have to initialize this part. So I'm calling init stack, what should be the arguments that I should pass? How many arguments do I need to pass here while initializing the stack? Don't take so much of time. This is how many arguments?
2.
We have to initialize the stack. What happened? What is the problem? Simple stack code. Hello.
Sir,
What are
if
the
we take
arguments?
the size of the
Yes,
stack.
so I have to specify this the maximum size there. So accordingly the allocation will be done, right? So I'll be passing that one. So maybe I'll be passing here 2 or 3 or 4, whatever. And what else do I need to pass?
The stack reference.
Yes, stack reference or the stack variable. In this case, stack object, whatever you say. So is that I'm willing to initialize S1 or S2, right? So that also have to pass, right? It's a simple procedure. So the procedure will take the variable name or the object name, whatever you say, and the size of the stack. Is that fine? Is that fine?
Yes, sir.
Because these are normal
Sir.
functions, there are normal methods. Init stack, that's all. So this much is enough. Now if I call init stack s2 comma 3, then it will be initializing s2, otherwise it will be initializing s1, like this. So what I have to write here is what's the prototype here? Stack. What is the prototype? Say
Int.
stack s comma int x. That's enough. What it should return? Init stack, nothing to be returned, right? Do you need to return anything here?
Prototype, we don't write the object or variable. No,
Anyway,
just
I mean, I may not specify this, but stack comma int, let it be stack comma int. Not a problem. I know that we may skip this also. Is that okay?
Yes, sir.
So in the
Yes.
push and pop, if I would like to push something, I have to say which particular stack you would like to push. Okay, I would like to push something in S1, and I would like to push the value 10. So push also, and what it will return? Push might return, if it succeeds, it will return 0, 1. If it fails, it will return 0 or -1, whatever. So it might return some integer value, and it will accept. So how many arguments push will have? Quickly.
2. Stack
Stack
int.
point. Okay. And then pop. If I would like to pop something from S1 or S2, I don't know. So if I like to do it from S2, that is enough. I don't have to pass any other arguments, and I can just write cout. So pop returns the value that you have popped out, and it accepts the variable, the stack variable from where you would like to pop out, right? What I have to pass while I would like to display something in the display function?
Stack. Stack.
the
Stack variable,
object.
stack object says to, so it is just stack, that's all. Void. So all these 1 2 3 4 are done. Then clear stack. So clear stack, what will be the clear stack? I have to again specify which stack you would like to clear or deallocate, right? Clear void. Now what about is empty is full? Is empty, who should be calling? Probably I will be calling is empty in the push, and I'll be calling is full in the I'll be calling is full in the push and is empty in the pop, right? In this case, S1 can directly call it also. S1 can call is empty, you can call also is empty S1. Okay, write cout. So this is also possible. So is empty also will accept the stack variable, and it will return the integer variable, true or false or 0 or 1, whatever, right? And is full stack. Is that fine?
Yes, sir.
So this is a typical, and once you have done this, so these are what are these? These are the prototype declaration of the functions, because it's a procedure oriented language, so of the functions. And after this, what we should do, we have to one by one come up with the definitions of the functions. So in it push, then I write stack s index, write the details of it, then void or int pop stack s index, sorry, this is in pop, and here within this is empty, I check if not is empty, then do this. So whatever is sorry is full is empty, like this. So these details you can, so you can implement one by one all the functions. So these are the function bodies, right? So that is how it looks like. So if I get back to the code, this is where the code is. Just a minute. So can you see the code? Is it visible?
Yes, sir.
So you see we have got the functions, the function prototypes, then we have got the structure declaration, the declaration of the structure, I mean sorry, the definition of the structure. So we have only done this end of the structure declaration, and then we are trying to define the functions. So these are the function definitions, and in each case you can see the we have passed the stack object and the value to be initial and the maximum size in case of int stack. In case of is full is empty, we are passing the stack object to check whether it is really full or empty. The clear stack is push stack, we are passing the stack object and the value to be pushed, then pop display. So these are all pretty simple things. So only thing is you can notice here is in the init stack we have actually called new init, new int is dot size, because this is a size variable which actually stores the size of the stack. So what I did here in the init, I have initialized s dot size as x, and then instead of calling malloc, I have just called s dot size. It creates a block, and s dot a points to it because a is a pointer to integer, right? So these are simple things. So then I have assigned top to -1, n to n should be 0 here, right? Because it just counts the number of elements. It is no elements are there. Delete is like this. It basically deletes the entire block pointed by s. Is full is this. If it is full, then we say we increment and then assign the value to it. In s dot n is also incremented, returns 1, else it writes stack overflow and returns -1. Pop means it checks if it is not empty, that stack that we input, that we pass, it will get the s dot top of s dot a to x, decrements n and returns x, otherwise it will return stack overflow, and displaying the value in a suitable format like this. So here I have called init stack. So this is the stack variable or stack object initiated, instantiated, or an instance created. Now this is just, so what does it mean here? So just you have some allocation corresponding to that object. So you can count the number of data members and their respective sizes. You can add them up and you can find out how much space it requires, and it will be, because it's local, it will be from the heap stack segment, right? So in each stack it will actually allocate the space. It will have some allocation in the heap, a points to that, and it will be size of 20. So you can say maybe say 2. So it's a stack of at most size 2. so it can accommodate not more than 2 elements. So then it is push, pop, and all this. Okay, so hopefully this will work. Let's see. What's the problem? Okay. Okay, I'll check this later on. I mean, let's focus on the actual thing. So is the structure clear? This one. So if
Yes,
you
sir.
are aware of, so let's I understand there will be some minor mistakes that have probably there is some steps that are mistaken, so I'll take care of that. Before I pass it on to you, I'll correct it. So let's see the procedure oriented approach. So what it says, you have got, so stack is a data structure, it's an abstract data type which comes up with a set of data variables along with the set of methods which works on it. Although it is cohesive, so general C++ notion is you cannot combine them together, although it is possible here, but we have not combined it intentionally. And because you have not combined it, because you have got the methods not a part of the structure itself or the class itself, what you see, the problem is every time you call a method or a function, you better call it as a function, to push, pop, or display, you have to pass the object stack, the stack object s1, s2, or s3 explicitly as a part of the parameter, right? That is one thing that we observe. Hello?
Yes,
Yes.
sir.
And whatever arguments it requires, you have passed it. Now we have got a list of prototypes and you have the details of it. Now let us see how we could have done it using, say, okay, let me just show it here itself. I think it's pretty trivial. So here, so what is the change here? You see, the change here is that we can still make it so you can write here struct or class, doesn't matter, the same stack, the name of the data type is still the stack. Now we say that this we call, now we keep using the object oriented terminology. So member data. Now earlier, because we have not mentioned anything, it was a structure, all were private, all were public. So the problem is, if you have called so from this, so here if you write is s1 dot top, you can easily write that, right? So you can, so here the fact is, if I write here s1 dot top say equals say 5, you could have done that, and that could be something very dangerous, right? So you probably don't want to have direct access to the top, but because these are all by default public, or I mean it is the way, so you can do all these things. Now here if I have a refined code like this, where you can see that now I don't rely on explicit, or I mean default access specifiers, I just specify. So what should be my policy now? So the policy may be that, see, the pointer, the contents of the pointer I don't want, because I don't want others to know. So now you see, when you buy a car, so the thing is the manufacturer will decide that what should be the customer's interface or the driver's interface. So you probably don't need to know everything that is inside the car, whether there's a motor, or whether there's a, I mean, engine, or whether there's, I mean, how many pistons are there, and all these details you really don't know, don't want to have. So the thing is, when the car is built, so it has shielded everything except giving some interface through which you, the driver, can drive, or maybe somebody, the passenger, can take a ride and all this. And in case you have got some problems in your tires, you can fix it by removing the tire and putting a new one. So this the minimal interface that you have got, so that is important. Otherwise you could have had a car without any the outer covering, and you can see everything, and you can probably try to attempt to do changes to everything, fix it and do it and make a complete mess out of it. So in case of stacks also, we know that there are 3 or 4 data members and there are 7 uh, uh, member methods. But when you think of a object-oriented design, your decision next step should be that how much should I reveal to the outside world? I mean, how much a user of the stack who is going to just use the stack to push something or pop something should be getting access to, and how much should I hide from that person so that he's not bothered about the finer details. Okay, he knows that I just want to use the stack. So if we keep that in mind, probably to push and pop, you really don't need this access to the a top or size. So that's why I made this private, because these details, why should I care about? Like when you use a Python code, you write a Python code, you really don't care about what is the size of the array and all this. So you try to hide everything and anything and everything that is possible. I mean, the designer has tried to hide from you. Just that I have to add, I have to delete, and I have to search and all this. So this is what applies here also. So the interface says that I would like to, once it is private, means I would like to hide it from the hide them from the external world or the user of the stack. But this n, maybe I would like to reveal. So if you want at any point of time, if you would like to know the value of n, you can do that. And maybe accidentally if you change it also, doesn't matter. The rest of the stack is probably written in that way, in such a way that this n will not impact, the value of the n will not impact. But if you want, you can get access the value of the stack, number of elements in the stack. In terms of the member methods, you can see that I have put here, you see, all the member methods inside, and here I have ended the end of the stack. Okay, so that is what I did. And here another point is, now when I have this stack object, s1 is a stack object. Now using this, so now what happens, this s1 is a stack object. So this stack object, what is the allocation of space? Definitely equal to this. That is fine. But now, because you have included all the methods also within the stack, within the class or the structure, now you can, as you can refer to s1 dot, say for example, s1 dot n, which is a public data member, you can access any other public methods also. Init stack, push, then display, then pop, these are all public methods. So just you say that, because you treat them as your members, and you can just say s1 dot init stack, s2 dot s1 dot push. And what is the nice thing that happens in terms of the arguments that you need to pass here?
One argument.
So what, I mean, earlier, because they were not a part of your definition, this init stack you have to pass s1 from here directly, right? Here you have to pass. But now s1 invokes init stack as its member. Got the difference? Push earlier used to pass push s1 or s2 or whatever. Now s1 calls push, s1 calls like this. So got the basic difference here?
Yes, sir.
So
Yes, sir.
I mean, mostly I am trying to highlight this for the C++ coders. So sorry, the C coders. So you see the difference, basic difference. Now, because those procedures which were earlier completely outside your structure definition, now they are a part of your structure definition. Now they are your members. So as you refer to data members using dot operator, earlier also you could have done that. Now here also, here you can access the public methods also, public methods, member methods also using the dot operator, and that saves you one argument because you are explicitly calling it like that. If there is some s2, so s2 would have called s2 dot init stack like this. So this is the basic difference. And here is the end of stack. You see, this is the end of the stack, and everything has been included here inside. Okay, so I think this is clear. So let us see if it works or not, if it runs. What's happened here also? is a problem. Init stack. Oh, I have not. Sorry, I have not compiled this one. G++.
Sir, you are not audible.
Sir, you are muted.
Hello, can you hear me now?
Yes, sir.
Yes,
Yes.
sir.
So how long I am not audible? I don't know.
Sir, 3 minutes.
Okay, so anyway, yeah, you cannot see me that I'm still talking. That's a problem. So have you got that? I think the one that I'm explaining. Have you?
Yes, sir.
Are you getting the code?
Yes, sir.
Hello.
Yes, sir.
So what I meant to say. So I don't know where from I got disconnected. I mean, my voice got off. So what I mean to say
Sir,
is,
after we got the output.
yes, okay, from the output part. So output, I think you can trivially find out what is done. So what I say is the size of the stack is 2. So that's why after I insert 2 element, if I try to insert the third element, it gives a overflow message, and I call the pop twice, so it pops out, and then it gives an underflow message. That's all. So that is what it says. And so what I wanted to focus now is how I write this, how I actually show it so that it is readable. So I have got data members and I have got member methods. Now in the data members I have got private and public. In the methods also I have got private and public. Now what I was highlighting, that is empty is full. It's something like, opening up the engine and trying to find out that what is there and all these, how many pistons are there uh, in the light. When you have the light, so you really need to know that what is the wattage and all this. So it's not required. So this is empty and is full. It's something in the previous case, in the earlier case, you really don't have any option to hide it, right? Because you are, anyway, these are all exposed, this, because you cannot put them inside your structure definition. But now you have the provision to put them within your structure or class definition. And if you really don't want it to be revealed, just for sake, so you are not afraid that the user is going to tamper it, rather you don't want the user to know, to be bothered about all these details, because uh, the user will feel that what should I do with all this. So the basic focus will be, once you have found out how many methods you should have for that particular definition, you should know that what minimally I should reveal, all the minimal methods that should reveal, so that the any user, you are writing and I'm going to use your class definition. So what minimal things, what minimal methods should I need to make use of it? So just declare them as public, and rest whatever it is, put it as private. because probably those will be called by your public methods itself, so they will not be required or called by the user of your class, right, from outside. So that's the basic policy. And in case of member data also the same thing. If you don't think that this is really required, so it's better you hide them. You may make everything as private and don't allow access to any of the data members without invoking some public method. So that should be the policy. Now once it is figured out, so then the member methods, first you list the private ones, then the public ones like this, and then in the methods member data, and in the methods also first the private methods and then the public methods. So that should be the that may be the approach. But can you find out some problem here in this way we write this? I mean, in terms of readability, the stack, it has got 7 functions, it's fine. Now let us assume that we are writing some class xyz which contains 50 methods. So if you start, and maybe some of the methods that the definition of the method spans maybe 100 lines. So if you start a class definition here, it will go on and go on and on, and maybe the end of the class, this end of the class will appear not after just 70, say right now it is only 72 lines, it may appear after 7,000 lines also, or maybe after say we don't know, maybe after say 700 lines. So how to get rid of this problem? Are you getting my point?
Yes, sir.
Yes, sir.
So how to get rid of this problem? What is the solution for this? So I'll just complete it. So just one more point. So the thing is, what I did, class stack, and I did here the public and the private data members int ax like this, public float f, private, then maybe is empty and all this. So but I'm writing the details of it, then is full, I'm writing the details of it, then push, then pop, then details. So this goes on like this, and this is the end of class display. So can you see it goes on and on like this? So what can be the way out for this? Hmm?
Sir,
Hello?
to reduce what, sir?
No, I'm to increase the readability. What is the option?
Sir, we can declare prototype and define later.
Yes. So just focus on this about the syntax. So ax whatever it is, then sorry, I mean let it be private, public, say int, say y, and then say again private. Now when you are defining the C, just like that C code also, when you are defining the private and these methods, so you basically write this is empty void, because now they do not require the object to be passed here explicitly, right? So is empty, is full, then push, then pop, then display. Okay, as it requires, like int and pop, then display, these are void, int, and then void like this. Okay, and you basically close it. So it's the end of class definition. You close it, so it becomes more compact and readable. So even if it is, even there are 50 functions, so it will end up within say 50-60 lines, right? Now after that you go for the definition. So you have the definition of the methods, right? So now one by one you do that. So is empty, so is empty void, and I'm writing the details. Now is full, Now, is that enough? If I keep on doing like this, like this, like this afterwards, so this becomes more readable. But is that enough? What I'm missing here? Now this is empty. You see, if I write this is empty, it was just like this is empty is nobody's. I mean, how you associate this is empty with this stack definition? This is full is the stack definition. This was just like some other function. How can you specify that this is empty or this is full is a part of this stack definition which I am writing it outside? How to make it possible? How to make it syntactically possible?
Sir, scope resolution.
Yes, so those who know it, so they know that we can use the scope resolution here, right? So what is the use of it? So this will be the end of this class. So just mention it and I'll complete this. So here I'll write, so this is empty is this stacks is empty. So just write this. Okay, write this part and then write void. So this also, instead of writing it like this, got it? So this now makes you yourself also when you read it, because you may have multiple classes within your same C++ code, or even if you don't have it, so it becomes really difficult to find out that this is empty is a part of the stack. So the compiler, when it compiles, it does not know that. Now if you write this, the compiler when it compiles, it knows that okay, this is empty is a part of this, and here you have declared the prototype, and here is the details of it. But you have just intentionally you have put it outside so that the definition becomes very compact and the details of the methods, definitions and all this will be outside. Got it? So this is another use of the scope resolution operator. Okay, so just see the code, and I've already written the code, so I'll just show it and it will be the end. Sorry, this is the so you see how compact it looks like. Okay, so this much. So within this, at a glance, you can see what is the interface provided publicly, what is the interface that you have hidden completely. I mean there is no interface provided to the public, private and public, what are the data members. So everything you can read from it, and if you are really interested to know the details of a particular method, you just come up with this, and this is the scope resolution operator through which you are specifying the details, right? So now this becomes more readable, and this is how you should write your codes from now on. Okay, and the rest of the thing is same. So just if I write here G++ stack scope resolution, it just does the same. So the only thing is this is definitely much more readable, as you can see here, compared to the other one. Okay, so this much for this class. In the next class I'll continue with the some other syntactic details, and the objective will be to write. So the stack structure, I mean now we'll not call it a structure anymore, we'll prefer to stick to the term class. So the stack class I have written, I have shown the use. I'll just show that how the objects reference and the objects address will be dealt with, those syntaxes, and I'll be mainly taking up the code to write the linked list class. Okay, that will be interesting. How we organize. So I know that everybody of you, I mean most of you know how to write a linked list code, but how we organize using that object oriented code, let us see that how it works. In the next class I'll try to cover it. So tomorrow is I think there will be no tutorial because of this Saraswati Pujo, so that will not be there. But so Wednesday we can have a class if you are willing to, because generally the concept says that there should not be any studies during these 2 days. So may I take a class on Wednesday morning, or it will be later on? I mean Wednesday we have got a theory class also. So what will you do?
Sir, you can discuss it with the CR.
Okay. So CR will take a poll and the opinion, and the majority, as it says, it will be decided. Okay, fine. So the CR, is he there
Excuse me,
in the class? Hello? Three
Sir,
CRs.
three CR, sir. Two of them are probably here. Sir, one of them is traveling, sir, so he's not.
Anyway, so I generally talk with one of them, but anyway, so CRs, you just inquire in your group and let me know in advance so that I can prepare the slides well ahead of time. Okay, so Wednesday I may take a class in the morning, the tutorial that we are supposed to have in tomorrow, and if it is not possible, then I'll take the tutorial on Thursday first half at some point of time. But Wednesday, if possible, I would like to take the evening class. I mean the afternoon class, the scheduled class. So let me know how people reacts. Okay. Any question till this point? Hello.
excuse me, sir.
Hmm.
Sir, I'm facing a problem, sir, in assignment 2.
Hmm.
Sir, in number 3 about